All right, you're going to want to turn in your Algebra 1 books to page 63 because we are going to be going over some rules as we learn about properties of real numbers and using those properties to simplify expressions. Specifically, we're going to be looking into properties of addition and multiplication. But remember, subtraction and division aren't that much different from addition and multiplication. Subtraction is like adding the opposite of a number, and multiplication and division are related because division is like multiplying by the reciprocal. That's what we talked about in a previous lesson. But in this lesson, we're going to talk about some properties. And I know I said rules, and you're like, oh, great, I'm going to have to memorize a bunch of new rules. But actually, you're going to find that most of these are pretty common and familiar to you. Okay, so let's learn some properties of real numbers that we will use to simplify expressions. Here we go. The first property we're going to talk about, we're just going to note in our notes that these are properties of addition and multiplication. And if you're thinking about these in terms of subtraction or division, you actually have to do some mental work to figure out how these properties apply in those cases. But first of all, we're going to take a look at what's called the identity property of addition, okay? And that is this: for every real number A, and again, that can be any real number, so that could be rational integer, so including negative numbers, including fractions, irrational numbers, square roots and pi, and also just the numbers we're used to dealing with, the positive counting numbers or zero. Okay, so every real number A, this is true. A plus 0 equals A. Hey, I told you this is going to be easy. I could also say 0 plus A equals A, and we'll learn about why that is in just a second. So for example, 5 plus 0 equals 5. Why is it called the identity property? Because the result of doing the arithmetic here results in the same number I started with. Hey, can you imagine, is there an identity property for multiplication? Is there something we can do with multiplication that would result in the same number that we are putting into our equation? Why, yes, there is. A times 1 equals A. Okay, so either of these arithmetic operations will result in the same number that we started with, adding 0 or multiplying by 1. Now, don't get these confused. Obviously, multiply by 0, you get 0. That's not an identity property. That's a zero property. Okay. All right. Well, that was an easy one. Let's get into one that's a little bit more difficult, the commutative property. You hear the word commute in there, and I hope when you hear the word commute, you think about moving around, okay? The commutative property of addition is this: A plus B equals B plus A. It doesn't matter if I move around the A to be behind the B, I can add in any order I want to. I could do this another way. I could say A plus B plus C equals B plus A plus C equals C plus A plus B. It doesn't matter what order I do this. It's always going to be the same as long as I'm adding the same three numbers. So when I'm just adding numbers, order doesn't matter. That's a commutative property. There's also a commutative property of multiplication, and it is the exact same thing. The commutative property of multiplication says that A times B equals B times A. But I could also make this A times B times C equals B times A times C equals A times C times B, or any other combination. So it doesn't matter what order I multiply, I'm always going to have the same end value. Okay, so that's a commutative property. Now we talk about another property that you may have heard of, the associative property. And there's an associative property of addition and an associative property of multiplication. And again, just like with the commutative property, the associative properties are going to be pretty much exactly the same. So again, and I should be putting these statements here. So I'm just going to go back up and do this. It's for every real number A, and then this one's for every real number A, B, and C. I just want to make sure we're noting that we're working with real numbers here. And then for this one, it's the exact same thing. So I'm just going to copy that little rule down here for every real number, A, B, and C. Okay, same with the associative property of addition. For every real number, A, B, and C, if I put A plus B plus C in parentheses. So let's just take a look at what I'm doing. I'm adding A plus B first, and then I'm adding C. Okay, I'm adding A plus B in parentheses. That signifies an operation I'm doing first. That equals A plus, hey, I could add B plus C first, and then add A, and I'll get the exact same thing. So the associative property of addition says it doesn't matter what order, not only does it not matter if I switch around the order of things, but I can add things together grouped in different places, and I'm still going to get the same result regardless of what I add first. It's very similar to the commutative property of addition. Same with the associative property of multiplication. And what this should be telling you is that addition and multiplication are actually very flexible when you're working equations, because when you're dealing with these numbers in equations, you're going to end up with values that can be moved around in the equation in any order that you want them to be. And we're going to see how that looks in just a minute. So again, for every real number, A, B, and C for multiplication, A times B times C, let's see, I'm sorry, A times B times C equals A times B times C. It doesn't matter what order I do it in, I'm going to get the same result regardless of whether I multiply A times B first or B times C first. And you can look at the examples in the book on page 63 on the right-hand side, showing that all of this holds true for real numbers that we're using these arithmetic operations with. Okay, so let's take a look at some examples of how this actually plays out in some real problems here. So we're going to look at example 1 on the next page. I'm just going to take this box and move it over here, and then we'll just delete everything. And example 1A. All right, so the question is, which property is being demonstrated for each of these? So for example 1A, you see 1 times 8 equals 8. Which property is that? Well, that one has to be the identity property because it's showing you that it's the same number, and it's of multiplication. All right, the identity property of multiplication. Let's take a look at 1B. That's not perfect, but it'll do. Okay, 1B, 13 plus 5 equals 5 plus 13. We're changing the order and getting the same result. That is the commutative property. If we're moving things around, commutative property of addition, because we're adding. Letter C. And when I look at letter C, 3 times 4 associated together with parentheses times 7 equals 3 times 4 times 7 associated together with parentheses. This one's going to be the associative property of multiplication. And then letter D, 12 plus 9 is associated together with parentheses. Plus 5 equals 9 plus 12 plus 5. Oh, wait a second. This one's tricky because I see that association there between 12 and 9, but the same two numbers are associated together on the second part. I just flipped their order around. Don't be fooled. Just because it's parentheses doesn't necessarily mean it's associative. You have to look at whether the order of the numbers is changing. And here, that's the only thing that's changing is the order of the numbers. I'm adding 12 and 9 at the first part, and then 9 plus 12 the second part. This is the commutative property of addition. Don't be fooled of addition. All right, let's take a look at example 2, and we'll look at 2A. Tell whether each statement is true or false. So using our properties, is GH equal to HG? Well, yes, this is true by the commutative property of multiplication, but we need to use real numbers to prove that this is true. So let's do, I don't know, 6 times 4 equals 24. 4 times 6 equals 24. There we go. Hey, by the way, you could make these numbers decimals. You could make them negative, make them 0. It doesn't matter. This works for all real numbers. The only thing you have to do is make sure you're multiplying. First of all, I wouldn't use 0 because that's a specific property, the 0 property of multiplication. You don't want to use something that relates to a different property altogether. And also, you do need to make sure that you are not using, like, so I wouldn't use 1 either. Okay, so don't use anything that relates to another property of multiplication. Make sure you're using something that is uniquely suited toward the property you're looking at. In this case, any number other than 1 or 0 would probably be a good bet. All right, let's look at example 2b. And this one states that, let's see, b plus 1 equals b. I don't think there's any number for which this is true. But if I look at an example, let's see here. What if I did 6 plus 1? Well, that equals 7. It is not equal. So I'm just going to write not equal. That's my not equal symbol to 6, right? So there's an example of when that doesn't work. All right, so we've seen these properties of addition and multiplication. Now we've seen some examples of how they play out in the real world. All right, next we're going to take a look at example 3. And in this example, we're going to see how we can justify the steps to simplify an expression. Now you have to pay attention because I'm going to walk you through this in a very step-by-step way. And this is what's going to be looked for every time you get one of these questions in the homework. So you'll see something like 16 plus 3x plus 4 as an expression that you need to simplify. And the first thing you're going to need to do is get like terms together next to each other. So if you have things that are multiplying the x, coefficients multiplying x, that's going to be rarer for you in Algebra 1. But this is the thing you really need to watch for. Do I have any constants that are just by themselves without a variable? Here I have 16 and 4 are just constants by themselves without a variable. The first thing you're going to need to do is get those next to each other. Okay, so I don't care how you would normally work this problem. I'm going to tell you that what you're going to be required to do for this type of problem is get the constants that don't have a variable right next to each other. So 3x plus 16 plus 4. And then you need to state what property you use to do that. Hey, what property allows me to move things around when I'm adding 3 numbers? That was the commutative property of addition. Okay, so that's what you need to do. You need to make sure that you start by getting like terms, in this case, the constants of the variable next to each other. The next thing I'm going to do is I want to add that 16 and 4. And I'm going to be very explicit about how I'm going to add that 16 and 4 by putting it in parentheses that's the next thing I'm going to do. I'm associating those together. Hey, what did I just use? I used the associative property of addition. You have to do that in order to get these questions right. You need to actually group together the things you're going to add together before you add them. And then lastly, I'm just going to go 3x plus 20. And then I'm just going to note over here that I added the numbers together. So I'm just going to say add. There we go. So that's what you're going to be required to state for this. Let's do one more and make sure you're paying attention because I'm going to expect to see all of these exact steps as you simplify ones like this. Here, in this case, we have 25 times 1 over 25 times y, okay? Now, how am I going to combine these? Well, first of all, I need to get the things that are like terms right next to each other. So I'm going to say this is y times 25 times 1 over 25. And that's going to be the commutative property of multiplication. So I need to move like terms next to each other, first step. Second step is I'm going to put the thing that I'm doing in parentheses. So I'm going to take 25 times 1 over 25. That's going to be my next step, is to multiply those two numbers together. So I'm going to associate them with each other to show that that's the next thing I'm going to do. That's the associative property of multiplication. And then lastly, I'm going to actually do the multiplication. 25 times 25, 25 times 1 over 25 is, okay, now pay attention because this is kind of an important. I'm going to end up with y times 1, because I actually have to do that multiplication. So I did the multiplication here. But then y times 1 is equal to just y, because it's the identity property of multiplication. Okay, so make sure you have all of those steps down. And it's pretty much always going to be the exact same thing. Get like terms together, commutative property. Group the terms that you're going to do the operation on, associative property. Then actually do the operation once you've got those terms grouped, because now by order of operations, you can do what's in parentheses. And then for multiplication only, you're going to have an identity property at the end if you end up multiplying something that equals 1, and you need to get rid of the 1 by just writing the thing, because y times 1 is 1 by that identity property. All right, feel free to take a look at that consumer math example that walks you through using this one more time. I strongly encourage you to go through that so that you can get a little bit more practice identifying the steps to solving a problem. And then your assignment will be 1 through 30 in the practice.